But cool. 87 scramble string. Given a string S1, we may represent it as a binary tree by partitioning it to two non-empty substrings recursively. Below is one possible representation of S1 equals great. To scramble a string, we may choose any non-leaf node and swap its two children. For example, if we choose the node gr and swap its children, it produces a scrambled string, I don't know, all great or whatever. Okay, okay. So return of that. Okay. This is also a problem where having n would be nice. I think you'd do some divide and conquer thing. Cause okay, how would I think about it? Like, yeah, I mean, I think we could just do some divide and conquer thing. Though I don't know about the running time. Because you could have a degenerate case where it's like n square, right? Like we just take off one character at a time, then it'll be n square. But okay. So I would have a helper. Let's just start with S1, S1, right, S2, right. It's just so that I don't pass in the string, though. Maybe I could just pass in the string. Maybe that's easier. But there are always going to be some contiguous chunks, so I think that's okay. Right. Just return as S. 3 - 1. Yeah, maybe we could cache it. Okay. And now we want to see, well, which one is the scrambling one? S2 is, okay, so S1 is the good one. Okay, we took a G, then we know that we want to chunk these two. Is that reasonable? I guess we just have two sets and then we do a rolling window and then we recursively can, the sets are the same. I don't know how the set equivalents work in Python, but let's give it a try. Okay. Well, let's make sure they're the same length. Otherwise, okay. Let's, I guess we should also do a precondition check that yeah, okay. I guess I need it. Can they contain duplicate strings? I guess so. Okay, let's actually make this a date. Okay. for x. So okay, if I guess also okay. So these are just some preconditions that allow our helper to operate in a so the things we're going to do will keep them invariant because otherwise they won't be true. But okay, let's just say for I want to do more brute forcey. I guess there's only n square thing, so we could just do something more brute forcey and cache. Maybe that's easier. Actually, well, it depends what n is. Is it n square? It's like n to the fourth, right? Excuse me. Not sure about the performance of this one, because you could probably do some smaller precondition. But then the base case is a little trickier. So now we're going from left to right. Now, so if is s of s1 nav to offset, it's not an offset actually, but let's say index. So if this is true, well, probably have to cache that, but okay. Okay, and the other possibility is the reverse of that. If this is equal to it's gonna be weird off by ones. That's why I'm a little worried, but it actually has two, right? Minus offset, but plus one. Something like that. Well, that's unfortunate. Oh, I don't have a base case, so of course this is never gonna be true. Okay, right. There could be some pruning that I do. We'll see about that. But we have to get it right first. Such a mess. Let's print out a tree. I mean, that's fair, but why doesn't index go to 1? I put back in. Okay, so it does do stuff. It just doesn't make it that far. Probably have an off by 1 on the tail end of this. And also have negative numbers somehow, which also doesn't sound great. Okay. This is the other way. Yeah. Maybe that's one of the reasons. Still wrong, but at least it's wrong in a better way. Sometimes that's all you can ask for, right? Okay. It doesn't get very far, which is not great. So 1 should be true, hopefully. But I don't know that I'm matching the right things here. Oh. Oh, that's the right length at least now. But I guess I have to check this. This is the one that I think will actually allow the swap part to handle. It seems like it's off by 1. Okay. I mean, now it looks better. At least on this side. But now I have to figure out just to make sure that my second half is right. Maybe we could just do this. Yeah, see, this is off by 1. Still off by 1. Oh, no. That's just printing, maybe. Okay. Not sure this is performing enough, to be honest, because they don't tell you what n is, which is always a little tricky, but I'm just going to submit it and see if I get a time limited exception. Oh, well, or that. So it is a scramble, but how is this a scramble? CBA? Well, I guess it's just 2 sets of things. But I do things very exhaustively, so that is curious that this fails. Unless I have it off by 1, which is also very possible. Because I always take the for now, right? Take the A and then A. That's good. And BCBC, just BCBC, right? That should be a good one to match. Yeah, that part is definitely true. And then 1201. Oh, let's do something even more basic. So that does give me the right answer. So why is this one? I'm just adding it to my tests. force 0, 1 and 1, 2. That should be true actually. What is that force? I shouldn't call this though, but is this the parent? I don't think so. 0, 0, 1, 1, that's 4, that's fine. Let's just see all the branch points. That's why I want to know the 0, 1, 2, 1, which is 0, 2, 2, which should be true. Just not by 1, is it? Oh, is it just me printing off by 1? No, this is weird. Oh, this has 2 left. Ugh. Well, that explains it. Also unfortunate. How did that pass other stuff? It passed a lot of stuff, right? Like this was... Yeah, it passed 170 tests with that typo. I don't even know how that works, to be honest. Right? Maybe just get lucky, I guess. Okay. My text pad, it's annoying. Okay, let's try again. Right. Okay, cool. I mean, that actually went in time. I was actually very worried about running out of time. And that one typo is kind of very unfortunate. I don't even know how that passed 170 tests with essentially very wrong code, but sometimes that's the way life is. You only realize you made mistakes until it's too late. But okay, cool. I mean, I think the tricky part about this is just figuring what n is, because I did an O of n to the 4th, and actually probably O of n to the 5th algorithm, roughly, maybe O of something like that. Actually, you could probably make some optimization based off the length. So I think you can actually cut down the space from n to the 4th to n to the 3rd by having the invariant that all the lengths are the same. Then you could. Then you just need to store the because if the length of the two strings are the same, then you just have to store the length, and you could cut down the one of these 2 dimensions or both, I guess, and then replace it with the length, which is implicit. So you can actually get down O of n to the n to the 4th. I think even though I use n to the 4th space, it actually is O of n to the 4th time, because I don't even O to the 3rd, because maybe O to the 4th. O to the 4th time, because I only do an index on this part, so it and everything else is calculated. So I think this is actually O to the n to the n to the 4th. But yeah, I've done a very brute force memorization. So I mean, it is what it sounds like. I don't know how I could describe this in an easier way. It's just that I given a string, I just take the first two characters or first one character and then look at either the first or the last character of the second string, and then so forth, and then kind of keep doing it recursively, and caching it. I have something in my eye, sorry. That's the algorithm. It takes a lot of memory and space, and it works, but yeah, how did my time go? I don't usually care of it. Yeah, I mean, I think this is relatively okay. Maybe it's a little bit on the slower side, but because one of the dimension is implicit, so that's why it's not actually O to the n to the fifth. But yeah, it's definitely a little bit on the hard side, but I think it is just like recursion, right? So just recursion, quote unquote, is a very hard one. But took me 25 minutes. Yeah, I don't know. I don't know if I definitely feel like recursion E problems is important, so definitely take a look at that. But it's okay. And I have changed the code a little bit cleaner. Yeah, I definitely could change the code a little cleaner. I definitely could modularize some of this stuff, like if nothing else, do all the pre-checks in one place. I think here it's okay. I also made a pre-optimization on the left and the right. You could maybe pass in strings, but that would definitely slow things more. I don't think. I mean, even though it is a little bit messy and hard to read, and that has come together, maybe there could be a couple of helpers, but like the core part of the code is just this for loop, which is well minus the print statements, like 3-4 lines, and a lot of it is just getting the index users right, which is not trivial. But I mean, it's even had a typo you saw, but yeah, I think that's what I have to say about this poem. So it's okay. It's brute force with memorization. So